Hi, and welcome to this podcast on simulating acoustics with Pachyderm for rhinoceros and grasshopper. In this podcast, I will focus on placing sources and receivers in your models. And we have previously already in the basic setup inserted receivers and sources, but in this case we will specify a little bit more how to use these in Pachyderm. So what we will do is, again, to simply write insert in the command line, and instead of just the omnidirectional source that we used previously, we will insert a speaking person. We asked where is the placement of the mouth. We insert that somewhere into our geometry, into our space. Man, woman, or child. Let's say woman. And we can ask for different modes of speaking or singing or shouting for that matter. And we say singing, in this case at least. Remember to move the position of the mouth to the correct height. And when we mark the source now and go to the properties, we will be able to see a differentiated set of values on the sound power level that is emitted from the source at the different frequencies. In the omnidirectional source, you may have noticed that the sound power level at all frequencies was 120. Should you have a more specified knowledge of your source, you can always edit these to set them to exactly the level that matches the source that you're working with. Then we will insert a receiver, or actually we will insert a series of 3 receivers, and they, as has been mentioned previously, can be marked and moved and copied in the same way as points can. So now we have receivers and sources placed in our model. We have checked that it's in meters and that the geometry of your space, your boundary space, is airtight. That means we are now ready to simulate, test the space. And what we'll do in order to not spend too much time waiting for the machine to finish the simulation is we will do a low order with just one reflection order of the image source solution. And ray tracing solution, we will just keep it at 1000 rays, even though that is too little for the volume of this space. Checking the environmental factors, and then simulate the acoustic of the space. Again, we will see up here in the command line that Pachyderm is explaining to us how far it is and how long time remaining there is before the simulation is anticipated to finish. It's casting or calculating the rays up to the number specified by you. And as it has completed here, we have now the possibility to go to the Analysis tab and have a look at the values that has been computed. So what we should take care of in looking at what is particularly different to the last example shown is that on the receivers we now have 3 different receivers, and when we mark the different ones in the interface, the Pachyderm interface, we will also see that there's a marking that shows which of the receivers have been chosen in your geometry, in your model. So again here, if you look at reverberation time on T30, we can see that our reverberation time is approximately 0.8, 0.7, Let's just quickly check at the different positions. They are closely matched or close to each other. That means also that our cutoff time is not entirely correct, but also not far off comparing to the estimated time or estimated cutoff time, which is based on 75 to 100% of the reverberation time, anticipated reverberation time. Okay, so but if you then move into and look, instead of the reverberation time, look at something like the definition, which is basically the a percentage ratio relationship between the early to total sound energy at these different positions. Then we can see in the more isolated space over here, we have a percentage which are relatively low. Normally we are interested in a percentage that goes at least above 50%, meaning we have a higher early to total sound energy at this position, in these positions. In this case, we have a too low in terms of, at least when we assess the space in terms of speaking conditions or for speech. If you then look at the positions right in front of the source, we have very high definitions here, which are values for definition, which of course is natural, seeing that we have supposedly a lot of early sound energy arriving to this position compared to the total sound energy of the space. And the same goes for the position over here. In this way you can start to understand the space acoustically through positioning several sources and through positioning several receivers and specifying the source to a higher degree than through a simply applying an omnidirectional source. Okay, that was it for this podcast on sources and receivers in Pachyderm. Thank you for watching.